can't wait for the calculus meeting.
Okay.
Can't wait for the
That's
calculus
it?
meeting.
No? Okay. All right. All right, friends, let's get rocking and rolling. We have got however much time we have left. I want to work on differential equations, and I want to make sure you guys get some feedback on that particle motion quiz from yesterday, which was stinky. Stinky.
Not in the camera, mister.
It's true, though, because everybody else is going to feel the same way. All right, so Jesus, I'm going to go over here. Okay, in the world of differential equations, and this is our focus for today. I think we're starting on page 67. You might want to write this down on a separate sheet of paper. There is a special, very, very, very special differential equation. And Roberto, you might want to join in on this one as well. That looks like this. dy dt equals k times y. Now, I want to get the vocabulary going here. You guys have already watched the video, so it's okay for me to go a little fast. Okay. dy dt is the rate of change of, I'm just going to call it stuff. It could be rate of change of the panda bears population. It could be the rate of change of the length of my hair. It could be the rate of change of the population of a particular campus. If you know that the rate of change of stuff is equal to k is a constant, but it has a fancy name. This is your constant of proportionality. Constant of proportionality. And y is your current amount of stuff. Everybody with me so far? Yeah. dy dt equals k times y. This is a directly proportional relationship, which is a phrase we haven't used in a while. Directly proportional just meaning the stuff on the left is a constant times the stuff on the right. When you see this, and you will see it, the solution, you can jump automatically. You don't have to do any work at all. Looks like this. Y equals c times e to the kt power. Y equals c times e to the kt. You may remember this from Algebra 2, from pre-calculus. You used different letters. This is PERT. When you see this, what happens is you get exponential growth. Okay? This is the differential equation that you're going to see. dy dt equals k times y, or maybe it's dy dx equals k times y. Whatever it's going to be, you're going to have this relationship. The rate of change of some stuff is the constant of proportionality times the current amount of stuff that you have. You're going to get this answer all the time. Now here comes the lightning fast proof, and then I want to get you guys working. Okay. So let's say you didn't know that and you saw this on the quiz. I want to get some hands. What would you do? You see this differential equation. What do?
You give variables.
dy dt equals k times y. What are you supposed to do in the world of differential equations? This is the most popular way. It's called separation of variables, and you guys would have watched 2 examples last night.
Yes.
Separate the variables. So I'm going to multiply by dt, and you get dy equals k times y dt. You're going to divide by y. dy over y equals k dt. We separated the variables?
Yes.
Now what?
It's 1 over 1.
Well, we've separated the variables. What have we done?
You take the integral?
You integrate both sides.
Yeah.
Now, I heard somebody say dy over y, that's the same as 1 over y dy. Integral of 1 over y dy, you guys ought to know natural log absolute value of y. Integral of k, where k is a constant. kt plus c, don't forget about Charlie, somebody's favorite superhero. To solve for y, you exponentiate both sides. Those guys are opposites. You get e to the kt plus c, which is the same as e to the kt times c. E to the c is your super Charlie. You get that the absolute value of y equals ce to the kt. How do we get rid of the absolute value bars? Uh-oh.
Plus or minus?
To get rid of those absolute value bars, you're saying that y is either the positive or the negative version of c e to the kt. C is a constant that you don't know, whether it's positive or negative, you're still going to get y equals c e to the kt. That was another little super Charlie, I'll get out of the way. So here's my point, friends. If you see this differential equation relationship, you could go through this. This was probably about as fast as I can do it. That was probably about 2 minutes. Or you see that relationship and you know what the solution looks like. Does that make sense?
Yeah.
Bridget?
Let's say that was free response.
Yep.
Can you just skip to that?
They will not do this to you in the free response.
On in the multiple choice criteria.
They're going to do it on the multiple choice. They won't do it on the free response. Sorry, that's not my being emotional. That's like a goldfish that's coming up. Not a real goldfish.
Ew.
Flavor blasted.
Ew.
They wouldn't. I would never see them do this on the free response because lots of students will memorize the form, and then how do you award points? How do you differentiate between the kid that knows all this beautiful differential equation stuff and the kid that just memorized the form? So they're going to stay away from that on free response, but multiple choice they're going to get you. They're going to get you because they're going to give you something like this, and you're going to go into beast mode and work all the way through and solve it. And Diego's just going to know it's y equals c e to the kt, and he's going to move on. He'll be done. Everybody good? All right, good. So I want to get out of your way. I want to give you guys the next 9 minutes. So between now and 9:08 on page 67, there are 3 multiple choice questions. I want you to get as far as you can with these. I'm going to come around. I'm going to check in on notes. I'll take attendance so I can keep my job and do all the things. We'll talk more at 9:08.
So every time you start,
I was so tired. And then I went out.
Oh, it's all missing the progress line, right?
And then I went out.
How do you know what to do that?
And then like they ended up having dinner at Dr. Barbecue. It was like later than
you see that
or like for me.
Yeah,
they lied to you, bro.
it'll be like prove that like why
I dropped the
so
I never ate it. I just drank the milk at 8:59. I just drank my turkey. It's someone else had 3 minutes. We were watching one of the juniors got their lady.
the test?
Yeah, George. Mr. T was looking everywhere for him.
Yeah, he was looking for me and George, but I can't believe it. So he didn't look for me.
And you have to learn like what time is after that?
I choose you.
Not just the meat and throw it in the solution.
If I saw them. Yeah, they're funny.
Did you look them up or were they?
No, I looked them up. Did it save on 10?
Because my internet's not working, so there's
No, you just there's the one.
no windows.
But you saw them.
I got your. I was like, I'm like, ya van a empezar con esto.
Yeah.
More and more.
I love that the Spanish one the most.
I know. Nah, so like, I swear to God, yo no escuché que dijo la señora que estaba una cebolla. I like, that cooking. When I looked back and I was like, there was a cebolla.
That's good. They decided to put a YouTube video on the audio y no se escuchaba bien. Like, se escuchaba todo.
And then,
No, like in Spanish, like it doesn't have, like it didn't have the audio.
And then like also like for that like CD player can like skip it the port. Maybe that's why I put maybe that's why I didn't hear la cebolla. Because when I looked at it, I was like, "There's cebolla, yes."
I can't wait for the 8
I'm gonna be so funny.
I think they're gonna be funny.
There's nothing to make fun of.
For 8? Yeah, history.
Learning?
They're dedicated.
I'm confused.
And then went to college for it, so not to look. I actually liked the video's comment, like the one that was talking about it.
It's like, Jose from the 80s, you ruined my life. Because I guess like, I brought my patatas because I was too into the Galapagos music. Like, it was good. Inez and Martin something.
You guys have like 4 minutes left.
Yeah,
Sir.
When you move, you have to move this piece here, right? It's negative.
What are you doing over there? You have a post-it?
this thing keeps switching sides. Last time I saw it was right here. Can I have the small one? Yeah. I'm gonna make fun of guys now.
Negative 2x times dy. Negative x squared.
Straight in you to hear me. I'm like, you gotta use it. Okay.
Because you know how it's negative 2x times dx? Like that.
Yes. I'm trying my best. That's the same. Yes, sir.
I mean, ladies and
It's okay, they make the same mistake as you. Guys, thank you. Wait, is it just just this Superman? Oh, mister, can you show us the meme so we can... Yeah, for the cat. Every time you finish the AP test, it makes memes on the internet.
For real, I had no idea. I don't Facebook, I don't Instagram.
Well, I'll show you. I can show you the physics one.
Okay, keep going. Hey, gentlemen.
I thought yesterday was
Ortega.
You want to tell me something? 40?
Hey, ¿dónde está tu small person? No, I can't make
You kiss up.
So when I got my money, I told them that go all the way through. Yeah.
Everyone knows you still have a
Thank you.
Number 15.
Did you say to that?
It's barely a hero. 2 minutes.
Well, it's good to know you. I don't even know the joke. Well, I lost mine.
You know, I'm not really grading these. I'm looking over and giving you feedback as you need to.
No, I think we just saved it.
That's the number.
Might as well.
I mean, it's good to know the movement.
1 minute. Not live. 2 minutes, 10 seconds.
So what is the answer? Okay, so I'm here, right? I know y equals 2 and then negative x
I believe you.
Leave your comments below. Do you like Ruby or you don't?
Oh, that doesn't matter. It's Y. I mean, it's
I'm sorry. I'm sorry.
Show him the
The C come down.
He solved it.
I think it's gonna be the same as that.
That's the end. Come down.
So supercharge just goes to the front.
It's kind of
Okay.
Oh wait, no, I know what you're talking about. Okay, that's cool.
It's A, right? Wait. You plug it in. Plug this in. Find it.
Oh, okay, yeah.
And then either way, this is negative. So it's
Yeah.
Wait, but then how do you get 1? Like, that was my key.
Because it's less charges.
We gotta plug in. A.
I just changed my answer.
So how does it become E?
Like, I knew it wasn't C or D because the X wasn't. No.
Yes, I do. You like my joke?
She likes my joke.
No.
I like when you plug in and say if
Wait, is it, wait.
Alrighty, friends. Spoiler alert. Here come the multiple choice answers. Number 1 is A.
Yeah.
Number 2, C.
Yes.
And number 3, if you made it there, is B. Okay, I'm curious, how many of you guys got the first 2 right? Okay, we're in a pretty good place. Pretty good place. I am a little concerned about the slope field one because these questions do show up pretty regularly. And the key to figuring out the slope field and the whole matching thing is you pick a point. Pick a point and focus in on that point. So a point that I might look at is, for example, over here, the point 0, 1. So x equals 0 and y equals 1. What do I know about the slope? What has to be true there?
It has to decrease.
Look at the tangent line there. dy dx has to be negative because the tangent line is decreasing. And so then I would look through my options and say, okay, which one or which ones tell me that when x equals 0 and y equals 1, I get a negative slope. Does that work here? No. That don't work. Over here?
No.
No, get rid of that one. Over here? Yes, it works for that point. It doesn't mean it's the answer. Okay, this guy over here, e to the negative x, e to the negative 0, that's e to the 0, that's 1. That's not negative, that's positive. 1 minus natural log of x, I can't find the natural log of 0, it doesn't exist. So you can't even be e. Picking that 1 point, you get c right away. What if, though, you had 2 options left? What if you had 3 options left?
Choose another point.
Jesus, what would you do?
Pick another point.
You pick another point. The other thing I saw some people doing is they said, you know what, forget about 1 point. What if I look up here in quadrants 1 and 2 where all the y values are positive? Anybody notice any trends? Anything that's true for all of those points? Oh, what do you notice? All the slopes are negative. So for any time the y value is greater than 0, your derivative has to be negative. So you could do that. You could also say, oh wait, but isn't it true that whenever y is negative, then dy dx has to be greater than 0? That works too. So you could look for like a point, or you could look for trends and whittle down your answer choices that way. And that's honestly what I would do if I was faced with one like this. And slope fields should be a high scoring place for most of you guys. Okay, so here's what I want to do. We're going to continue the good work time. If you guys could, okay, so first of all, the bonus assignment, if you choose to do it, is to finish problems 4 through 10. It's more separable differential equations, it's more slope fields. These should be the kinds of questions that you see them next Tuesday and you're like, yes, I know what to do.
I'm a fan.
I'm going to do it. Now, unfortunately, you're only going to see 1 or 2 of these, so don't get too pumped up. All right, on page, whatever it is for you all, you're definitely going to want a separate sheet of paper for this. On the bottom of page 71, this is a question that we've worked on before.
Is it?
I don't think anyone has perfect memory.
No, I barely remember.
Okay. Some of you struggle to find the room.
Thank you.
Okay. You guys have between now and I'm going to call it 9:28. That's 15 minutes to get as deep into this question as you can. This is an AP question, which means you should be able to complete the whole thing in 15 minutes or less. 5 minutes from now, I'm going to spoil it and talk through A and B, and so you can check your answers against mine and make sure you're on the right track. Part C is where all the points really are, but I want you to spend the time in A and B. Okay, we'll talk in a bit.
Please stop bullying me.
You bully me. You make fun of my
I forgot about that.
Does anybody have anything late to turn into me or anything that I need to grade?
What? I'll bring it to you.
Like, these are agreements that I've reached with.
Can I bring it tomorrow? I lost my progress more than somewhere in my room. You're very organized, okay? You haven't seen my room. You see my room. You never want to talk to me. I'm trash.
I try to pad I tried. But I just have clothes everywhere. That's the thing. Yeah, that's the only thing. I have clothes everywhere. They're scratching everything. Crazy Spanish? Yeah, I was just trying to write.
What do you want, women?
Find it and let me know.
Now I have 2 minutes to present.
What do you need for tangent? To find the equation of a tangent line? This should be like... You need a point? One of the mistakes that happens a lot when it comes to differential equations, people get so excited and they just want to start solving a separable differential equation. Don't do it at the wrong time.
I'm guessing the
Part A just says, use the line tangent to the graph of W. To come up with the equation of a tangent line, you need a point, you need a slope. That's all we're looking for here.
That's zero, isn't that
It's at the beginning of 2010. 14.
So the point is 0, 1400?
Yeah. So then the slope. How do you know? Oh no.
This is the slope 1.
What is this?
Minus this.
But DC.
Then you have to plug in something.
Yeah.
So the equation.
Right, you want to go here because this is your differential equation. This is your derivative. So that's where you get slope of the tangent line from.
Wait, is this it?
Yeah, so the good news is there's good stuff here. The bad news is you're doing it at the absolute wrong time. And so what would happen,
Oh wait, you wrote it.
you're going to see like later on in part C, oh, this is where I'm supposed to solve it. And then you're going to have to rewrite all of that work out. So you need to make sure that you're reading the question carefully and you know how to take action.
Is it plus y?
That's the same thing as
solving it out.
what are you doing? You're on the free response part of the test. Don't simplify. In fact, I got scared when I saw you do 1100 divided by 25. That was scary for me. That was scary and a waste of time. Okay, well, you should have also. Here's the problem. This 1 over 25 times w minus 300 should be a number. You want the slope. You want the slope at the point 0, 400. T equals 0, w minus 1400. All right, for anybody who is still on part A, the point that you were given is 0, 1400. The 0 is your t value, the 1400 is your w value. To get the slope at 0, 1400, you've got to plug in. So this is 1 over 25 times 1400 minus 300, and you know what that is?
Doesn't matter.
Nobody cares. Sheila knows that it's 44. And there's nothing wrong with the fact that you know that it's 44. But if you simplified and said, oh, it's 32, you just threw away the point. Mario, you need to wake up. Equation of your tangent line is going to be L of t is 1 over 25, 1400 minus 300, t minus 0, plus 1400. That's the equation of your tangent line. How much waste is there at time t equals a 4? Approximately 1 over 25 times 1400 minus 300 times a fourth minus 0 plus 1400. That's worth 2 points. I think what they did is they awarded 1 point for coming up with the equation of the tangent line and 1 point for coming up with your estimate. Hold on, Karina. This would be the kind of question that I would expect every single person is able to get right. And because this shows up so often. Karina.
You have to put W.
Well, you don't want, L is the equation of my tangent line. W, they're asking you to approximate the amount of waste at 1/4. That's what W measures. Okay. The other thing that they've asked you to do in part B is find d squared w dt squared. There was one like this in the video that you watched last night. What am I asking for?
Double derivative.
I want the derivative. That means, though, I want the derivative of this guy here. So I need to find the derivative with respect to t of 1 over 25 times w minus 300. The derivative of a constant times the stuff is 1 over 25 times the derivative of w minus 300 with respect to t. T is the variable here. The derivative of w with respect to t is dw dt, not 1. Now they said express this in terms of w, so now you take the dw dt and you go back over here and say, oh, this is 1 over 25 times w minus 300. That's your second derivative. There is another part in part B, but I want you guys to move on to part C. because I'm only going to give you guys about 4 more minutes here. Part C is worth 5 points. Your goal is to pick up all of them. Yep. So for the first 3 months, that's time to do.
Yep, it's just one to find the initial solution.
So don't we have to
Do the long
DYT?
click around there.
Yeah, that.
Yep. Tell me. Why? What is it that you're reading that says now is the time to
Wait, do we just take out y or y minus 300?
Take out this. Yeah, the whole thing.
solution? That's the thing that's
Will be
In part C, it's this phrase where they say, find the particular solution. That's the green light. That's the thing that says, oh, now I go solve the equation. Now I separate the variables. Now I do the things. It's that phrase, find the particular solution. That's why you spring into action here.
You divide the whole thing by
In fact, that's the only thing you can divide the whole thing by. Because that W and the 300, they're inside the parentheses. They're linked by that negative sign.
Yeah, because I think with the natural laws, they're like the, if you take the different out from like 1 over ax plus b, like it's 1 over a.
so it's the
ax plus b, but it's not.
this reminds me of they died yesterday.
They want you to solve.
Dude, like she, I think she took a bathroom break and then she just came up to us like English.
I need my
How about I said it to
I just hope Jackie.
Yeah, I got an answer.
They will know about the beef.
You know when you eat both sides?
No, they actually said
Okay, so E of the element cancel that, right? So then W minus 300 equals, and so this E right here is an E to the 1 over 25 plus C times E to the C? Or like, is it plus C all on top? Plus C?
You can do times C. Oh, no, not 1.
the derivative, that should be 1.
No, it's plus C.
Don't you break the C down? Because like the problem that we just did, like,
Wait, how do you write it?
okay, so,
Oh, this one, 300 divided by 25.
it will be E to all of this? But like,
Wait, is C equal?
but is there like a second part that is like times?
Right, when you have this e to the 1/25th t
Why does
plus
that
c,
sound like you
you can
give me
rewrite that as e to the 1/25th t times e to the c. because you get addition in the exponent, that means it came from multiplication of the bases.
Wait, I did.
So like, I know you bring the C down, but like, does the C stay there, or like, you can,
Well, it's a two-step process. You say it's e to the 125th t times e to the c. Since c is a constant, e to the c is also a constant. Alrighty, friends. Spoiler alert. Here it comes. That was more than enough time. Alright. So first order of business is you separate the variables. That means you divide both sides by the w and the 300.
Yeah.
They have to stay together.
Yeah.
Okay. So dw over w minus 300 equals 1/25th dt. First point. First point there. Now you integrate both sides, and dw over w minus 300 is natural log of the absolute value of w minus 300. The integral of 1/25 is 1/25th t plus c. If you got either antiderivative correct, they awarded a point. To solve for w, you're going to take the exponential on both sides. And then I rewrote that e to the 1/25th t plus c is e to the 1/25th t times e to the c. E to the c is really super Charlie. And then just like we've talked about before, to get rid of the absolute values, it becomes w minus 300 equals plus or minus the constant. Add 300 to both sides. Use your initial condition, c is going to be equal to 1100. And there's your final answer. That would have been worth 5 points. How many of y'all would have earned all 5 points?
We earned 4.
4. Okay, I can deal with 4. Michelle, what point did you not earn?
I forgot to finish with Charlie.
Oh, you forgot to use the initial condition. So did you stop at 300 plus c e to the 1/25th t? Okay, Destiny, what's up?
We added 301 and we got c equals 1099.
Oh.
We didn't treat it as big. We didn't do the super Charlie. We added.
Oh, so did you have 300 plus c plus e to the 1/25th t?
Yeah.
Okay, that's fine. It should have been multiplication. Okay. All right, cool. So let's put that away. Honestly, that's all the time we have for differential equations. I got to tell you, I'm a little worried because the 2 problems that you guys watched for homework last night were really hard questions. I am worried that some of you are either not watching the video intensely and absorbing the stuff. I also worry that some of you might be getting somebody else's notes and copying down their notes and showing those. If that's what you're doing, you're missing the whole point. And the only person that you're cheating is you.
Yourself.
That's it. That's all there is. All right, you guys can take out the quiz. Didn't you get the copy for you?
No.
There should have been one with your name on it.
Yeah, it should have been.
I took the
All right, we're going to talk about A, B, and C pretty quickly. Here we go. Part A. I knew this was going to be a zinger. I knew people were going to get all screwed up with this one. Good stuff looked like this. They said average value, and they said the integral 1/8 minus 2, the integral from 2 to 8 of the acceleration. Because you wanted average acceleration. Here's how we find average in calculus class. How many of you guys did this? You started this way. I thought there were more than that. And then I think people got confused. They're like, what am I supposed to do from here? What's the integral of acceleration? The antiderivative of acceleration.
Velocity.
Velocity. So what you've got is 1/6 times the velocity from 2 to 8, which is 1/6 times the velocity at time 8 minus 1/6 times the velocity at time 2. The velocity at time 8 you had on the table, the velocity at time 2 you had in the table. That's one way you could do it. Here's the other way that some people did. They said, let me look at the velocity at time 8 minus the velocity at time 2 and divide by 8 minus 2. That works as well.
That was it?
Both ways get you average acceleration. That's it. Okay, that was 8.
I don't.
Okay, and sadly, it was just one little point. One little point. Okay, part B. Do the data in the table support the conclusion that train A's velocity is negative 100 meters per minute at some time between 5 and 8? Most of you said yes. Why? Why does it have to be true? Why does it have to be true that the velocity has to be negative 100 on this interval 5 to 8? Most of you said something like, oh, well, it just has to be true. The data supports it. How?
IVT.
If you're going to use the IVT, you have to know something about the function you're talking about.
Differential.
No. To use the IVT, continuous. Is the function continuous?
Yes. Yes.
Yes, Jose, how do you know the function's continuous? What do you know about the velocity function?
That it's differentiable.
It's differentiable, but in order to be differentiable, that means first you have to be continuous. So you get the continuity piece for free because I told you differential. Okay? And so here's where you say the IVT applies. Okay? Now the other thing you then have to do, you have to look, you have to name them. What's the velocity at each time? Well, this guy's 40. This guy is negative 120. What's so special about negative 100?
It's in between.
It's in between. It's in between. Does the velocity have to be equal to positive 100?
No.
No.
Positive 100?
No.
No, it could be equal to 100. Does it have to be equal to 100? No, because you're not inside that interval. So you'd want to see something like v sub a at time 8 is less than negative 100, which is less than v sub a at time 5. That's what I was looking for. And then because this is true, yes, the velocity has to be equal to negative 100 at least once. Everybody okay? Mm-hmm. Okay. All right, part C. This is where we started to get a little more success going. A little more. I think some of you got beaten up so badly in parts A and B.
You good?
Some people just gave up. Okay, time t equals 2. Train A's position is 300 meters. So we know the position at 300, and the train is moving east. Write an expression involving an integral that gives me the position of time A at time t equals 12. How do I get the position at time 12 if they told me the position at time 2? It's your fundamental theorem of calculus. The position at time 12 is equal to the position that you know, the only position that you know, plus an integral from 2 to 12 of v sub a of t dt. Writing that down get you the first point. From here, it was a matter of using the trapezoidal approximation, and most people did well with that part. Most people did well. One thing I want to say, because this still keeps happening. A lot of folks are saying, okay, so it's going to be a half. What are the data points for the first interval?
40 and 100.
Is it 40 and 100?
Yes.
They're saying like 1/2 times 40 plus 100 times 3. Love it. Plus the next one times 3, plus, and then the last one was what, times 4?
Yeah.
That's great. Don't simplify. Nobody cares what the numbers equal to, Sheila. Nobody cares. Don't simplify. The other thing that's still happening is people are writing this integral sign in front of the computation. This means take all this stuff and now find its antiderivative. Don't write that. If you write that, you are throwing away a point. Throwing it away. Don't do that. Okay, part D, last one. Okay. I know I'm going fast, Yvonne.
You have to write the equation.
You have to. They asked you first of all to write an expression, so that was the expression. Okay. The people that were most successful in part D are the people that drew a picture. Okay, here's your origin. Train A is going this way. What's train B doing? Train, not the opposite direction, train B is going north. You have a velocity for train B. You have a velocity for train A. I knew this was going to be an unkind question. I knew. Because train A is going east and train B is going north, that makes a right angle. And what are they asking for in the question? The distance, the rate that the distance changes. So the distance between them, let's say that that's your distance. I kept calling it C. For the distance between them. Anybody have any clever ideas for how we might get something involving distance here? I wouldn't even go to SOHCAHTOA. Jackie, what could you do? Pythagorean theorem. A, B, and there's C. A squared plus B squared equals C squared. Right? A is how far train A is. B is how far train B is. C is the distance. What I want to know is what's the rate that that distance is changing. What are we going to do? Derivative. The derivative of A squared?
2A.
Oh, I'm sorry. The derivative of A squared with respect to T.
2A dA.
2A times dA dt plus the derivative here?
2B times dB
dt equals 2C
dC
dt, and that got you 2 points. From there, you just needed to plug the stuff in. I knew part D was going to be rough. I wasn't expecting A, B, and C to be as rough as it needed to be. I think take away from today, when you're watching the videos, you need to go deeper in the internalization. See you guys later.
Just doing a sort of plan.
Yeah.